Hey guys, so we're going to go over multiple representation of polar coordinates. Just note first that I've given you r and theta here. So I'm just going to plot the point to kind of give you a visual of where the point is. So r means that you're going to plot a point on the third circle. So the third circle, where exactly? It would be at the angle -3 pi over 4. So some of you are familiar with how to graph -3 pi over 4. Since it's negative, you go clockwise, and 3 pi over 4 is a distance of 135 degrees. So you're going clockwise a distance of 135 degrees. Um, some of you don't like to deal with the negative angles, so that's fine as well. For those of you that don't like to deal with the negative angles, you can just simply change it by finding its coterminal angle. So remember, coterminals are found by adding or subtracting a full circle, and they're going to be at the same place because when you add or subtract a full circle, you're starting and stopping at the same place. So for those of you with calculators, you know how to work the fraction key. You can just take -3 over 4 plus 2. Since I don't have a calculator here, I'm just going to add by doing the crisscross applesauce method I showed you in earlier videos. So -3 pi times 1 is -3 pi, so that's criss, plus, because there's a plus in the middle, cross. 4 times 2 pi is 8 pi. So crisscross over applesauce. 4 times 1 is 4. And that would give me 5 pi over 4. So this can be also seen as 5 pi over 4. So I'm going to plot a point on the third circle at where 5 pi over 4 is. 5 pi over 4 is in the third quadrant right there. And in addition to that, I inadvertently did the first additional point. So mind you, there's an infinite amount of representation of polar coordinates. We're just going to go with the simplest ones because it's only asking for two. So the first one is you can take r and whatever theta is, you can add 2 pi or 360 degrees depending on if the angle is given in degrees or radians. And you can add or subtract a full circle as many times as you want. It's still going to be the same point. So for this, I'll keep the r as 3 and take the angle and add 2 pi, which I've already done, and that's 5 pi over 4. And if you note, I'm on the third circle at 5 pi over 4, so it all represents the same point. Now the second one is changing the sign of r. So don't think of r as negative. It means you're changing the sign of r. So in this case, I'm going to change the 3 to negative. And when that happens, I take the angle and I add or subtract 180 or pi in this case as many times as I want. And that would also give me another representation of that same point. So I'm going to take the given angle, -3 pi over 4, and I'm going to add pi, which fraction form pi over 1, and I'm just going to do my whole crisscross thing again. So -3 pi times 1 is -3 pi, plus, cross, 4 times pi is 4 pi, over applesauce. 4 times 1 is 4, and this would be at pi over 4. So this point is also at that point in blue. How does that work out? Well, if I go to the angle pi over 4, which is right here, I can't just plot a point on the third circle because r is negative. So whenever r is negative, that means you go directly across the origin. So if I'm at pi over 4 and I go directly across the origin for -3, I'm at that same point. So all of these represent the same point. I hope this helps, guys.